Okay, this is for question E13 in section 1.2. And here we're getting at an interesting question of age discrimination. So I will save you the time of reading all that. When you get to this, first of all, you read this. Using counting methods you may have seen in a mathematics class, the number of ways to pick 2 out of 10 workers to lay off is, and then we just have some symbols. Now this may have seen is an important part. You may not have seen this, or you may not remember. This is called a combination, but if you're rusty on it or have never come across it, you might wonder, how do you handle this situation because you have no idea what's going on. So one way would be to email me and say, Dan, I'm on question E13, section 1.2. I have no idea what this 10C2 means. You may go to the textbook first, but I believe the textbook doesn't do much job of explaining this. So email me would be one option. Another option would be Googling. So what would we Google here? This number of ways to pick 2 out of 10 seems to be the key thing right here, because we may not know how to actually enter this if we don't know it's called a combination. So let's go with this pick 2 out of 10 and see what we end up with. So again, I'm just Googling here, pick 2 out of 10. And I'm just going to take this first. Let me make this a little bigger here. Pick this first one. How do I count the number of ways of picking, choosing? And if I scroll down here, I notice this symbol, this 10 over 2 in parentheses that I saw in the problem we were just doing. So I may read a little bit about this and figure out that this exclamation point here is called a factorial, and what that means is 10 factorial would be 10 times 9 times 8 times 7 times 6 all the way down to 1. 2 factorial would be 2 times 1. So it's just a number operation we can do on a positive integer that will give us the product of every integer every positive integer less than that integer that we're starting with together with that integer itself. And one thing that you'll notice is this formula. So when we have 10 over 2, this is called 10 choose 2. This is what they explain here. We take 10 factorial over 2 factorial, and then we also have to add this 10 minus 2 factorial. And this is the difference between a combination where order doesn't matter and a permutation where order does matter. If this is completely new to you, I would suggest Googling combination and Khan Academy, and they have some videos that go into this a little more. So as we write these out, notice that the 10 minus 2 would just give us 8 factorial. And because this 10 factorial is 10 times 9 times 8 times 7 times 8, we want to cancel out as much as possible. That's why this is written as 10 times 9 times 8 factorial, so that these 8 factorials will cancel, and we just have 10 times 9 over 2, which is something we could calculate to be 45. And of course, we don't need the numbers 10 and 2, but we do need this number to be at least as big as the bottom number in order for this to work, because we want to end up with an integer that's the number of ways to choose this bottom number of elements out of the top number. So for an example, they're using salad ingredients. They have 10 of them. They want to choose 2 out of the 10, so this would be 10 choose 2. In other words, 45 different ways to choose 2 ingredients out of 10. So that was all coming through the Google search. In other words, how many different ways could we pick 2 out of the 10 workers to lay off? Well, there'd be 45 different combinations of workers that we could lay off. Now, out of those 45, this is where the question is starting to focus. How many would have an average of 56 or greater? So in other words, if we're choosing 2 out of these 10 workers and then taking the average age, so for example here, if we choose these 2, we'd add them, divide by 2, give us an average age of 29.0, because 29 is 25 plus 33, and then that sum divided by 2. We want to know how many of these pairs would give us an average age of 56 or greater. Well, in order to get 56 or greater, we need either both to be 56, which is impossible because there's only one 56, or one to be higher than 56 and one to be, well, certainly we need one higher than 56. And notice that there's only one person who is higher than 56. So there's the 64-year-old right here. In order to get a pair with an average age of 56 or higher, we have to have this person right here as one of our members. If we take the average of these 2, the 2 oldest, notice that we would add them, divide by 2 to get 60. So that would be an average age greater than 56. That would meet the requirements. If we took 64 plus 55, that would be 119 divided by 2 is 59.5, and that's also 56 or greater. So we could either have this pair, this pair, this pair, or this pair. That's 4 pairs so far. Let's see if we'd still get the average age we need if we use the 48-year-old. So 48 plus 64 is 112, divided by 2 is 56, and that just barely meets the requirements, right? We need to be 56 or higher. So this 48 would be the youngest person that could combine with this 64-year-old to get the average we need. In other words, there's 5 different people we could pair up with this person to get the average age of 56. So the answer is 5. So if we were just to randomly choose a pair out of these 45 possible pairings, 5 of them would give us an average age of 56 or greater. 5 out of the 45. So choosing a random pair, we would have a probability of 5 divided by 45, in other words, 0.11 chance of getting an average age of 56 or greater. So when we're looking for age discrimination, we want some kind of event that is so uncommon that it's unlikely to occur by chance. So this type of event, getting an average age of 56 or greater, would occur 11% of the time if it was being done randomly. In order to have some kind of discrimination basis, we need to be 2.5% or less. And right here we have 11%. If we can convert this to a percentage, we have 11%. We do not meet this standard because we're not under 2.5, so we select no for this discrimination. In other words, it would not be too uncommon to get an average age of 56 or greater just by randomly choosing 2 people to lay off.